So there's a few important forces to know when working in A-level maths, the first of which is weight. Now, don't get this confused with mass. We quite often say, oh, I weigh 80 kilograms. That's not a weight, it's a mass. To go from, you can convert between one and the other. So say, for example, you've got a mass of 80 kilograms. Because our acceleration towards the ground is always gravity, unless obviously there's some other forces acting on us, but let's take G as gravity, we could do 80G and that would become a weight. Okay, so weight always acts straight downwards and is measured by multiplying mass by the force of gravity, which you should be aware that G is 9.8 meters per second squared. You should know that from SUVAT. Okay, next is the normal reaction. So by the way, we can say weight is the letter W normally. So say you've got a particle here and the only force acting on it is its own weight, you would label this arrow W. So next is the normal reaction. And we can give this the letter R for reaction. And this is a force exerted on a particle by a surface. So say, for example, we have a table, we have a particle on top of it. There's no other forces acting on it other than the weight of the particle itself. Well, there must be another force stopping the particle going through the table then, and that is called the normal reaction. And the normal reaction is always perpendicular to the surface. So regardless whether our plane is flat, like in the example there, or we could have a plane at an angle, the normal reaction will always act perpendicular, so 90 degrees to the surface. Okay, next is friction. And we'll assign this the letter you would assume, F. Okay, so this is a resistive force, and we give it the equation F is less than or equal to mu. So mu R. So this mu is what we call the coefficient of friction. Okay, so basically a measure of how two surfaces interact with each other. So you could imagine sort of sliding a block of ice on a block of ice, both very, very slippy. The coefficient of friction is going to be very, very low there. The friction overall is going to be very low. Whereas, say you take a drag race, so like a drag race car, and put that on the right surface, so like a drag strip, the coefficient of friction needs to be very, very high so that the car can accelerate aggressively. So the coefficient of friction varies quite a bit. But it is always greater than or equal to 0. Okay, can't be less than 0 because friction always opposes motion. So say, for example, again, we go back to a particle on a table. If I'm pushing it this way and there's some force acting, some friction acting on it, then the friction will be acting in the opposite direction. So that way. Okay, so next is thrust. Now, this is essentially force exerted by or on a particle. So imagine pushing a box up a hill. So you've got a hill here. Here's our box. If I'm pushing it up, then the force I'm exerting on it, the technical term for it is thrust. What thrust am I giving to the box? We don't assign a letter to that. Next is tension. So this is sort of a measure of how tight a rope is, sort of. So it's similar to thrust in that it's resisted by friction, but requires a string, rope, or wire that is taut. So you could imagine, let's say I've got a pendulum, it's hanging from a rope. Well, we've got this weight pulling down. The weight, let's just say it's mg. We don't know the mass of the particle. There must be, because obviously it's dangling, it's not moving down, it's not going up, there must be some force pulling it up as well, and that's actually the tension in the string that would have to be equal and opposite, so mg. And we assign tension the letter T for tension. All forces I've mentioned and any forces that you will come across, these are the main ones, but they could mention other ones like perhaps air resistance, and they'll give a force value, will all be measured in newtons. So newtons, and we use the letter N for that unit. So say, for example, something was 7 newtons, you would write 7 N. Okay. So just a quick note, forces that are perpendicular to each other. So for example, like this, you've got this particle, you've got gravity pulling it down, and you have some force pushing it this way. these forces, because they're perpendicular, so they meet at 90 degrees, they don't have any direct effect on each other. Okay? Now, that isn't to say they don't have some indirect effect. So, another example, if you have this ball here, and it has friction working against it, well, friction, because its F is less than or equal to mu times R, this is a vertical force. R, it's the reaction force, and F is a horizontal force. So friction, it's acting, if we're wanting to go this way, so we're pushing the particle that way, friction would act in this direction. So you can see they can have an indirect effect, but they don't have any direct effect on each other. Okay, so in this model, no friction or anything, they're not affecting each other, so you can completely separate it into vertical direction and horizontal direction. Whereas a model like this, while they're not directly affecting each other, you do need to consider the vertical direction and consider the horizontal direction. It could affect each other due to things such as gravity and friction. So when working with forces in A-level maths, there's quite a few different pieces of terminology that you need to know. The first of which is what a particle is. So a particle is a body that takes up a point. So basically, all this means is we don't need to consider the dimensions of the particle. So for example, if we had a plane here, we had a box on it here, you'd be worrying in real life about sort of the surface area and its contact with the plane. If we describe it as a particle, we're imagining that its size doesn't really matter and we can just imagine it as an infinitely small point. Next is a plane. Now I've just briefly mentioned it there, and this is a flat surface that the particle is acting on. And by flat, I don't necessarily mean like that. So a flat surface that the particle is acting on. And like I say, I don't necessarily mean that it has to be flat like that. It could also be on an incline. What I mean is it's not curved. So it's flat in the sense that there's no bumps in it. So next is smooth. Now this means that there's no friction. So the plane offers no friction. So as soon as you see the plane is smooth, don't worry about the friction forces. What's the opposite of smooth? Well, rough. If you can look at that definition there, I'm sure you can guess what rough means. This means the plane offers some friction. So if a plane is ever described as rough, you should then be thinking, right, there's some friction forces somewhere. The plane offers friction. Okay. Next is light. And this means the particle has no mass. Okay, so if a particle has no mass, then you don't need to worry about what it weighs or anything like that, or forces due to its mass. You can just ignore them. Okay, so next is resultant force. Now this one's very important because it's used in pretty much all forces questions. So the resultant force is the overall force. The overall force when all forces have been considered. And what do I mean by this? Well, if we had a flat plane there, some particle, one force pulling it this way, one force pulling it that way, and we give them some magnitudes, so say 20 newtons that way and 10 newtons that way, well, the resultant force, because these are in opposite directions, would end up being 10 newtons in this direction. So all I've done there is 20 take away 10. So it's the resultant force when you consider all of the forces that are happening, what actually happens. So next is static, and this just means the particle isn't moving. So the particle isn't moving. You might also hear them call this stationary, so they could say the particle starts stationary or the particle starts static. Isn't moving. Okay, so the next piece of terminology to know is what an equilibrium is. So this is when the resultant force is zero. So the resultant force is 0. This could also be used when talking about moments. An easy way to imagine this is if we've got some plane here, a particle, a force acting that way, a force acting that way. This one's 10 newtons, this one's also 10 newtons, and now we have to think about what happens. Well, they're in opposite directions with an equal force, so nothing happens. The resultant force is 0, the particle doesn't move. An easy way to imagine it is a tug of war. Both teams are equally as strong, so no matter how hard they pull, the other team pulls just as hard. It never moves anywhere, so the resultant force is 0, so you would say it's in equilibrium. Next is beam or rod. Beam or rod. Okay, so this is a long particle. So a long particle. Okay, so it has a single dimension which doesn't matter. So basically it just has a length. We don't worry about its thickness and we don't really worry about its length. So this might be used in pendulum problems. So you could have like a pivot there and this here. We don't really worry about the length all that much. You could have say a wall, a shelf, and some sort of support for the shelf. You could call this support, a beam. We don't worry about its length, we just worry about the forces that it exerts. Next is uniform. This means that the mass is evenly spaced across it. So the mass is evenly spaced. Okay, so used quite commonly in moments. So for example, if you had a piece of wood and we say that it's uniform, well, the center of mass will be right in the middle just there. So what's the opposite of uniform? Non-uniform. And it's exactly what you think it means. So it's not evenly spaced. The mass is not evenly spaced or spread. Not evenly spread. Okay, so again, a piece of wood, but let's say this end's a little bit more dense, so this end's a little bit heavier, so maybe the center of mass ends up here rather than in the middle. Okay. Next is rigid. Now all this means is that the body doesn't bend. So the body does not bend. Okay, so for example, if you had a pivot here, some beam coming off it, and you apply some torque to it this way, so it doesn't bend, so rather than doing this and curving, it just moves as a pivot round here perfectly straight. So next is thin. This means the body has no thickness. The body has no thickness. And you'll quite commonly hear this when you have particles connected with a string or a rope or something like that. They might say a thin, light, inextensible string or something along those lines. It's just the body has no thickness, i.e. we don't need to worry about it. And finally is inextensible. Okay, so again, quite commonly used when talking about a string or a rope or whatever connecting two particles. Let's say I have a particle here and a particle here, and I connect them with some sort of rope or string. If I apply a force on that particle going that way and a force on that particle going that way, well, if this was, say, a rubber band, it would stretch before the particles move, wouldn't it? Regardless of how much greater one force is than the other. If it's inextensible, it can't stretch. So the body does not stretch. Okay? So the body does not stretch is inextensible. So SI units are the standard system of measurements, and there are 3 important base units that you should know. The first of which is length. Now, we measure this in meters, which you can denote with an M. So, for example, you could write 7 meters as 7M. Okay? Next, we have time, which normally you might say hours, minutes, seconds. In this case, if we're working in SI units, we just use seconds. Okay? Which we denote with an S. So, you might have 1 minute, but we would write that as 60 seconds if we're working in SI units. Okay, so mass is measured in kilograms. Now, of course, there are imperial units. You could have, say, pounds. If we want to use this in terms of forces and everything, we want to convert to kilograms so that we're using SI units. You can, and obviously this is donated kg, so for example, 80 kg, 80 kilograms. Now you can, of course, combine these and make other units. So for example, speed or velocity is measured in meters per second, which is meters s to the -1. You can see that's a combination of the first two there. Okay.